An explanation of titration. A 75 milliliter solution of hydrochloric acid with an unknown concentration is titrated to the equivalence point with 27.3 milliliters of calcium hydroxide with a concentration of 0.157. What was the concentration of hydrochloric acid in the original solution? A description of the question. The problem says we are going to take a solution of hydrochloric acid with an unknown solution and add it to a 27.3 milliliter solution of calcium hydroxide with a concentration of 0.157. The unknown concentration of the acid, HCl, is to neutralize the base calcium hydroxide. We're going to use this information to find the unknown concentration of hydrochloric acid in the original solution. We have to begin by writing a balanced chemical equation. Now we will draw a picture. This is helpful because if you can convert the words of a problem into a picture or a diagram, you can solve any problem. Now let's make a picture step by step. Calcium hydroxide comes completely apart into ions because it is a strong electrolyte. You will have 1 mole of calcium 2+ for every 2 moles of hydroxide. Since this is an aqueous solution, the volume equals 27.3 milliliters, and there's a known concentration of 0.157. Now we are going to add 75 milliliters of hydrochloric acid with an unknown concentration to the solution. Hydrochloric acid is also a strong electrolyte, which means it fully dissociates in water. We are going to take the hydrochloric acid solution and pour it into the calcium hydroxide solution. The hydrogen atom bonds with the hydroxide to form water, and the chloride atom binds with calcium to form calcium chloride. Since we drew this picture, solving the problem will be a lot easier. You can refer to the picture instead of the words to understand what is happening in the problem. The next step is to ask yourself, what do I know about the given information, and how can I use the information in the diagram to solve the problem? We know that we have 75 milliliters of hydrochloric acid and 27.3 milliliters of calcium hydroxide. And calcium hydroxide has a concentration of 0.157. We know that to find the concentration of hydrochloric acid, we will use the formula concentration equals moles of HCl divided by volume. To find the moles of HCl, we will use the moles of calcium hydroxide in the stoichiometry in the balanced chemical equation. We will use the 2 in front of the hydrochloric acid and the 1 in front of calcium hydroxide. Before we begin to solve the problem, we need to convert the volume of both solutions from milliliters to liters. You can do this by dividing each of the given volumes in the problem by 1,000. We will now solve the problem by looking at the details. First, we will find the moles of calcium hydroxide. To do this, we will use the equation moles equals concentration times volume. Moles of calcium hydroxide equals 0.157 times 0.0273 liters. This will give us 0.0042861 moles of calcium hydroxide. Now we will use the moles of calcium hydroxide in the stoichiometry in the balanced chemical equation to find the moles of hydrochloric acid. You get the 2 from the balanced chemical equation for hydrochloric acid and the 1 for calcium hydroxide. You then get to cancel out calcium hydroxide, and the moles of HCl comes out to be 0.0085722 moles of hydrochloric acid. Now, to find the concentration of hydrochloric acid, which is we are asked to solve for in the problem, we will use the equation concentration equals moles divided by volume. You divide the moles of hydrochloric acid that we found in the previous step by the volume given in the problem that we converted to liters. After solving this problem, we now know that the concentration of hydrochloric acid is 0.114296, and this is what we were asked to solve for in the initial problem. Let's look at some common mistakes that occur during titration problems. The biggest common mistake is forgetting that the moles of hydrochloric acid can be found from the moles of calcium hydroxide by using stoichiometry. Be careful to not use the equation M1V1 equals M2V2. Another common mistake is forgetting to convert the given volume of each solution from milliliters to liters.